Alright, what's up guys? In this video, we're going to pick up some calculus here. We're going to evaluate another trig integral. So we're asked to evaluate the integral secant to the sixth theta d theta. Alright, so what you have to do for most trig integrals is kind of rewrite them and break them up a little bit. And that's exactly what we're going to do with this secant here. So I'm going to rewrite this as the integral secant squared theta times secant squared theta quantity squared d theta. Okay. Now, understand that this is the same thing as that. Remember, I have secant squared theta squared. I basically would just take the two powers and multiply them. And remember, if I have the same base, I would then add the powers, because then this would be secant to the fourth theta. And since I have a base of secant for both, then that would be 2 plus 4, which is 6. So I can essentially break it up that way. And I can break it up even further using more identities, particularly in this case using a Pythagorean identity. I'm going to leave the secant squared theta alone, but on the inside here I'm going to write this as 1 plus tangent squared theta quantity squared and then d theta. Okay, so again, it sets this up perfectly for substitution, and that's how most of these trig integrals work. You can rewrite them using trig identities, whether that be reciprocal identities, Pythagorean identities, half angle identities, double angle identities, whatever the case may be. Rewriting them sets you up for substitution. So in this case, let's let u equal tangent, or tangent theta in this case. So the derivative of tangent theta, that's secant squared theta, d theta, and hopefully you were able to see why that's the appropriate substitution, because we got the secant squared theta sitting on the outside. So we know that tangent would be the best selection for u, and if you see the derivative nearby, you know the substitution works. So then you get 1 over secant squared theta du is equal to d theta. That's if you solve for d theta. So what's going to end up happening is the secant squared theta will cancel out on the outside. Then you got the integral 1 plus u squared quantity squared and then du. The best thing to do at this point would just be to expand out what you have. So we know that 1 plus u squared quantity squared is just 1 plus u squared times 1 plus u squared. And hopefully you remember how to fold from algebra. That should give you 1 plus 2u squared plus u to the fourth. So now the integral is 1 plus 2u squared plus u to the fourth and then du. And now you can go ahead and just use the power rule at this point. So then what you'll have, and I haven't been utilizing equal sign, so I apologize. Okay, so now you just go ahead and do it. So you'll get u, we're integrating with respect to u now. So this will be u plus 2 over 3 u raised to the third power plus 1 over 5 u raised to the fifth power and then plus c. And all you have to do to finish this up is to just put the u back in. So remember what the u was. So the substitution was tangent theta. So you would just have to put that back in there. And that would be the final answer. So your final answer, we can go ahead and write it down. So we need to integrate secant to the sixth theta d theta. So I would just write my answer as tangent theta plus 2 over 3 tangent cubed theta plus 1 over 5 tangent to the fifth theta and then plus c. And I was able to get the plus c on the end there. And that'll be the answer. All right, so I'll circle that for you. All right, so hopefully that made sense. And if you got questions, I'd be more than happy to answer them. All right, so that's going to be some trig integration. I'll see you guys next time. Y'all take care.